Hi all, my name is Santosh and welcome to my YouTube channel. So guys, in this video I will be talking about the C++ operators and the types of the C++ operators, and I will be talked about the short definitions of C++ operators and the types of its. I will be talking about the types just like arithmetic operators, relational operators, logical operators, bitwise operators, and assignment operators, and increment and decrement operators, ternary, size of, comma, and typecasting, etc. I will be talking about it. So first of all, the arithmetic operators. What is arithmetic operators? It means it performs mathematical operations just like plus, minus, subtraction, multiplication, modulus. uh, we can also say increment and decrement operators. It means there should be also use the plus and minus operators as well. So about the relational operators means, what is the relational operators? It means it relation operators means it compares two values, two integers. So it gives the relations between the values. Logical operators perform logical operators, logical and operators, logical or, logical not. We will see in the practical lab in the today uh, video. So we see the bitwise operators, how the bit level will be performed, and assignment operators, and increment and decrement operators. We also see the size of operators and operator typecasting. It means it converts data type from one data types to another data type. So I will open my VS Code, and where we can practice our lab. So I will open it and directly move to the Visual Studio Code. So now this is the interface of Visual Studio VS Code, from where we can practice the C++ operators here. So at first I will write here, I will create a text file, operator types.txt, types of operators in C++. So we can write here the types. First I will be talking about the arithmetic operator. Arithmetic operator, that will be the plus, minus. So just like it performs the mathematical actions, just like mathematical operations, just like plus, addition, subtractions, multiplication, division, modulus. So what are the, first of all I will create a arithmetic.cpp file. So I'll increase the font size, so it will be very easy to understand. So the basic syntax of C++ programming language I will write here. So include IO stream using name space std. So int main, it will the return. So I will declare or initialize integers just like a equal to 5, suppose, and b equal to suppose 7. I can write here. So it will give you just like a, you can declare or initialize any variables as your requirement. So suppose I'll write 10, and I'll write, sorry, skip some 10 I write here. And first of all I use here what we are see out, arithmetic. So in real, why we use it? to end the line, it gives the new line. So I use here. So at first see out the plus arithmetic operators. Arithmetic operator means addition, subtractions, multiplication, division. So I will see out, use the output functions, insertion operators, uh, a plus a plus oops b mm, b and a plus b, a plus b and delay in real. It is the additions. I can write comment addition, additions. So it gives some, if I will turn off here from where I can, oops, I can cut file from here. So I'll give you the C out, and it gives the in my VS Code Copilot is enabled, that's why it's giving automatically. So I will write the, it's a minus b, oops, insertion a minus b in real, in real. It's now it's subtractions, and other one is multiplication. You can write just like here. And why this is happening automatically, Copilot is now enabled from here, that's why it's showing automatically about it. So the other is C out, C out insertion is modulus is given. C out, I will give you the no about the addition, subtraction, multiplication, division, modulus, and it gives you the this is the you can say the arithmetic operators, just like addition, subtraction, multiplication, modulus. It's very easy, guys. So just like it's a minus, plus, multiply, division, and modulus. The modulus is important because it gives the remainder of the value. So you can now click on play button, so the output will be something is missing, return 0. Don't forget to write. So you can play, click on play button and run code. To run the code, click on the play button. So the output will be displays here. It takes some time, so it gives some, I will give you a space here, so the value will be space, and also it gives you the space. So I will save, and once again I run the program, so the result will be like this. So 10, first of all, integer, what is happening in this program. So I have written the basic syntax of C++ programming language, and the to perform the arithmetic operations, operators, the operators that are the subtraction, addition, subtraction, multiplication, division, and modulus. So I declare or initialize two variables, the int variable a equal to 10 and int variable b equal to 3. Both are the integer type of variables, positive variables. So as per the declaration of the variables, I have performed the arithmetic operations here. It's like addition, subtraction, multiplication, division, and modulus as well. So the result will be uh, uh, here you can see here a plus b equal to 13, a minus b equal to 7, a into multiply 30, a divide b gives the 3, but a modulus gives the b, a modulus b gives the 1, because if you divide the 10 by 3, its remainder will be 1 and the division will be the 3. So modulus and division both are the different things, so you can understand like this. So, and the second, I will be talking about the two relational operator relational operators. You can say the relations it means the it compares two values. It compares, uh, if you think it compares two value. To learn about the relational operators, it means you have to declare the uh, integers or variables. So after declaring or initializing the variables, we have to use the relational operators to compare the variables. Just like which one is if that is equal or not equal, that is greater than or less than, and we can use greater than or equals, less or equals. We use it like this. So in arithmetic operator we have finished. So I create the next file, and this icon is used to create a new file, and this icon is used new folder. So I can create a new file here by clicking here. So relational.cpp. So relational operators compares two variables, just like if you declares uh, suppose a equal to 10 and b equal to, suppose if you initialize 3, and it compares at least two variables, it's like equal to or not equal to, greater than, and less than, greater or equal, less or equals. You can compare like this. So I have I write the basic syntax io stream. So using namespace, just like int man, this is the initial phase to starting the C++ programming language. So io stream oops io stream. So these are the basic syntax of C++. And in the second, we see the relational operators. That is the now I initialize a value, declare a value, suppose int a equal to 10, and uh, in one line I declares so b equal to 3, just like it suggests automatically. So I will write this. You can write as per your requirement. So just like I we in this lab I'll be talking about the relational operators, just like, and before this I will print a message and what is happening and what is lab about that. So see out relational operators, relational operator. So I'll be use here the mm, in real in the line. So I'll see out slash a is greater than b, and so I can use insertion operators, and a is less than b until, right here until, mistake, spelling mistake, int l. Intel. So mm, it is happening. I have to use it as a bracket. So so see out a is greater than, oops, a is greater than, so I have to write a is greater than b. So I have to write like this: a is greater than b, and I have to write it inside bracket. Using bracket, a is greater than b in real. See out a is equal, you can see just like a you can use equal operators to check its similarities. So uh, I can write it sorry, oops, equal. So a equal b, and you can use here C out, oops, and a is equal or greater than b. You can use a is equal or greater b. You can int real. This is used to go to the next new line. So what is happening? Why is it showing error? So something is expected in errors in real. So int a ent t here. So in real, what is happening? A is greater than, a is greater or equal. A is greater, sorry, a is greater or equal, not equal or greater. Greater or equals, you can see here, and other is C out. Oops. A is less or equal B. You can take a bracket parenthesis. A is less or equal B int L semicolon. Do not forget to end with the semicolon because it terminates the line. Why we use it? It terminates the line of statement. It means this statement will be terminated. It's terminated now, and after it we can use or we can write another statement. So this it gives the, suppose uh, what I have read, less, greater, equal, lesser, equal, and not. Last one is C out. A is not equal to B. A not equal B int L int L. So this I will explain you about the code, what is happening in the relational operator. So I have declared initialize two variables, just like int a equal to 10 and b equal to 3 in one line. You can also it gives to set the time and to gives the more readability in the code. So you can you can write or declare initialize variables in a line, in having the same line, so you can declare initialize like this. So relational operators we see, so a is greater than b and gives you what is happening. A is greater than b, it's true, 1. And relational operators always print the bit level. It will print the bit value true or false. True means 1, false means 0. So it keeps the, suppose I will write the documentation parts. true gives 1 and false gives 0. So the uh, I will show you to run the code and what is happening and what will be the result. So this a is greater than b, it's true, and a is less than b, it's false. It will give 0. It will give the 1. A equal b, it's false, it's 0. A is greater and equal b, it's greater than, and it's 2, yeah. And so a is less than and equal to b, it's false. And a is not equal to b, it means not, if the both it means a is not equal to b. Yes, it is not equal to b, but when you use the not operator, it will prints the true statement. So it gives the 1, it means true. So I will go here, 3 dot, and sometimes it will be disappear from here. You don't worry about it. You can use by the terminal also. You can run sorry, terminal also you can use it. So go to do 3 dots and use the run this code. So what is happening, look here. So I'm not giving the, so I will give the space. So press alt and click here, this sorry, uh, this here, here, give space. So the value, it is more readable. So go here and run this code. What is happening? Yeah, this is added. So you can go here, you can print like this, the result will be shown here. So exactly, this a is less than b, it gives the false. False means 0, true means 1. False means 0, true means 1. And a is not equal to b, it's true. So a is not equal to b, it's true, it gives the true value. True means 1. So this is all about the relational operators. uh, it is very important the things to remember, that it gives the comparisons. It means it compares the variables. When whatever you declare and initialize any variables, and it the relational operators uh, compares the initialized variables, just like greater than, less than, greater, equal, greater or equals. It means less or equal, not operators. These are the relational operators. I will show you its result in the lab practice. The not operators, even the condition is false. When the condition is false, it gives true. The condition is true, it gives false. Both are not equal, both are not equals. Even both are not equal, the not operators give you the true value. It means it is the just opposite. When the condition is false, it gives the true, and the condition is true, it gives the false. So both are not equal, even it's giving the true 1, so it is true. It is just opposite. Logical operators are used to perform logical operations, just like we use logical and operators, logical or, and logical not. So I will uh, create a new file, logical.cpp, and I will write the copy the code syntax. I will erase it. So this gives you a, this is the basic syntax, and other I will erase from here. You can do like this. This is the basic syntax of CPP. It means C++ programming language. I will write here the first of all I will declare, I initialize the variables. It perform the logical actions just like a uh, logical and logical or and logical not operators we use here. So we use a just like a we use bool operators data types and y equal to true. So oops, x equal to true and y equal to false. So I have declared initialize here. You can see. So to use the logical operators we use three things. The first one is logical and the second one is logical or, and the other is logical not. So I will compare to perform the logical just like a logical operations by using the and operators and not operators, logical not operators, logical or operators. So logical operators I will print here. So at first I will print a message logical operators. So Intel see out I will use the logical and operators. Suppose logical and x and p, sorry, y. I will give a space here and x and y int l. You can write like this. This is the so I have to use bracket, so it will be make it more readable. Logical and operators true false true false. So it gives suppose in other I will use you the suppose x y. So I will use the brackets parenthesis. So x y int l and I use the other one is x not y. I will use x not y int l. It gives you suppose uh, suppose x I will use x. So this will gives you the this is the and operator and and operators. So this is a we can say logical and we can say it logical and this is the logical or, and this is logical not. So I have declared initialize two variables. The first one is x true. This true means one. You can basically it is very important to know you to this means true means one. I can write here true equal to 1, false equal to 0. I have to use like this. So you can also initialize the variables. So that will be more easy. So I will show you. So you can run from here. What is happening? So the logical uh, AND operator prints the 0, logical OR means 1, and and the not logical not prints the 0. How it is happening? And now I will show you here. So see, logical AND means it is the multiplication A and Y. Suppose uh, 1 and 0. 1 and 0 means if you multiply 1 and 0, the value what will be the result? It will basically, it will obviously it will print 0. If you multiply, uh, it means multiplication, and end means multiplication, so it multiply the true and false. If you multiply 1 and 0, it will obviously print 0. And or means, logical or means the value will be true or false. If that value is true, it will print true. So it compares, it logically compares x or y, so true or false. So by default it will print the 0 1 here. So not logical not, x is a true, it means it is true, it will be print the 1, but we use here a logical not, so it will print the its opposite. So true, x equal to true, and if we opposite are inverse it, it will be become 0, so it's become the false. Now you can see here it is printed 0. So logical or and means multiply, logical or means you have to basically uh, it will print the true value, just like compare with between the two. If the out of the, suppose you initialize two things, two variables, and it will be positive, it will be true out of them, and the true value will be printed in the console. So you can see like this, you have to understand like this. Suppose I declare I will suppose x equal to, suppose I change, no, int x equal to 4, y equal to 7. I'll comment here, uh, I will comment here. So you can see here, if I print it, so go to the three dot and mm, run this program. So you can see here it's true. So x is for, basically x is for, if you change it y, and x, now you can see the another output 1. You can see true out of two variables. So you can see here 4, and you can multiply like this, multiply or 0. It means basically this is not done, but you can see, you can use like this, it true or false, it is very easy. So you can print this one. uh, don't worry guys, I will upload the code in my GitHub account, you can download from there, and you can practice before, because you don't, if you don't practice it will be very hard. If you practice for one or more two times, it will be very easy, because it is the, we have already discussed about the operators in C programming language, so you can, you are all aware about it. So um, this is the logical operators. I've seen the logical and, logical or, and logical not. This is notify, we can use and operators. It is the symbols, pipe symbols we can use here for or, and this is the not operators we have practiced here. I'll show you shown you to the lab of logical operators here. Bitwise operators basically in C++ programming language are used to manipulate data at bit levels. So uh, they operates, it means bitwise operators operates in integers, treating them as sequence of bits, just like binary representations rather than decimal values. It means the representation of bitwise operators in C++ programming will be the binary representations, just like 0 and 1s. These operators are particularly useful in suppose low level programming language as embedded system graphics programming, cryptography, so as well. So in bitwise operators you can see bitwise operators means these operators are the operators that are used to perform operations on the bit level on the integers. Suppose um, if you declares the integers, two integers, and the results performed in the bitwise operators will be in the bit level, so the representation of it will be shown in the bit level, just like you can see, you can say just 0 and ends. And while performing these operations, integers are considered as sequence of binary digits, that is 0 and 1s. And just like you can see bitwise AND operators and bitwise OR, bitwise XOR operator you can say, and bitwise NOT, left shift, and you can right shift as well. So bitwise AND operators, first of all I will show you, and just like I will show you in question 4, bitwise operators. So um, in bitwise operators it's like bitwise, first of all, AND operators, bitwise AND. Suppose you see the um, bitwise AND operators, it means it performs between two integers. It will compare each bit on the same positions, and the result bit will be set 1 and only if the both corresponding bits are 1, the symbol used to bitwise and that is and I will show you here. So it's like if you bitwise, I'll create a file bitwise.cpp, so it will be very easy to you, and I'll copy from the basic syntax, so that will be very easy for you. So I will show you bitwise operator. So first of all we have to declare a variables, initialize variables. You can use a, it's like a int a equal to 5, sorry, int b equal to 3. So these are the two initialized value. The variable a and the variable b is the integer type of variables, and when you use the bitwise AND operators, it perform each bit in the result 1 if the corresponding bits in both operands are 1, otherwise so it's 0. So if we convert it, the 5, if you, its value always represent as um, bit level, so it is its representation is I will create show you ms, and so it will be how to convert it, I will show you. Suppose I have the 5, what is the binary of the decimal 5, so I will show you. First of all I will print this, and I will show you the result of it. So in, if you find its result, it will be suppose cout mm, and bitwise, and its representation is always in b. So I will have to use it as bracket parenthesis and bitwise operators, you can say. And bitwise operators, it means bitwise, and you can say its symbol bitwise. You can say bitwise and its symbol is and. So you can see here I can, okay. So if you print, go to the three dot and use it, run the code and see what is happening. Yes, it's 1. Why is 1? I will show you. Suppose bitwise AND operators. This is the symbol you can use here for, and I have already told you about its definitions. Its representation is in the form of binary representation. So it means the result will be r 0 or 1. So how it is happening? So I will show you and mm, show you in pen. So suppose I've taken a pen. I have write 5. I'll take other. Oops. You can. I will increase its file. No, 5. You can. If you convert it in bit levels, do we will always divide it 2 to the 4. So its remainder is 1. I'll erase here. Yes, it's not minus. It's showing just, and 2 to the 4, its remainder is 1, and once again I have to divide it. 2 to the 2 1 the 2, its remainder is 0, and to representation the decimal value to the binary value have to go bottom to top. So its binary is 1 0 and 1, you can see. So the other number is 3 number, so I can write here 3. 3 is divided by 2. 2 ones are 2. Its value is 2. 3. So um, you can see here. Sorry, its binary representation is 1 and 1. So if you see, if you multiply, and means multiplication. So 5 equal to 1 0 1, and 3 equal to, you can say 1 and 1, 1 and 1. So you can say here 1 1's of 1, 1 0 the 0, and you can say just like a 1. So you can see here it's decimal 1 0. Oops, 1 0 0, 1 0 and 0 0 0 0 1, you can see here. So its value is always what is happening, that we can find here from it, just like a 0 0 1. So 0 0 1 means how you can say uh, it's binary, the decimal is 1. So that's why it's print the uh, result. Its result is 1, you can see here. Suppose you can use another, you can take another example, just like a, you can take a 7 and you can take a 4. So I will give you the next example. Suppose if you see the it gives you suppose I will show you. It gives you, suppose you 7 11, suppose you give, and you take a 7. If you run it, what will happen? It gives you a 3. It gives you a 3. How is it happening? How is happening? So it will give you the result based on the binary digits. So suppose if you give you, oops, if you give you 7 and something is 4, and what is happening? What will that result? It will give you the 4. And how is 4 coming? I will show you. So I will show you the pent, and suppose you take a 7 and you have to divide it. 2 3 is 7. It gives one remainder. 2 1 is 2, 2 1 is 2, and 1, it gives 1. So its corresponding value is 1 1 1. And if you divide 4, if you divide 4, it what it gives you? 2 2 is 4, 0, and 2 1 is 2 0. So it gives you a 1 0 and 0. If you use bitwise AND operator, then multiply it. 1 0 is a 0, 1 0 is a 0, and 1. And what will happen? 100 gives you a value. 100 gives you the what will the 100 value? It gives you 100 value. 100. It means the binary. This is the binary. If you find its decimal, what will happen? It will give you the 4. So the Visual Studio course, what is happening? It shows the 4. You can see here. So and the next one is, you can see the bitwise and other is bitwise or, you can see, or bitwise or. So the representation, you need to understand that bitwise means the representations. It is always in the form of binary digits. So bitwise or operation is performed between two integers. It will compare each bit on same position, and the result will be 1 if any of the corresponding bits are set 1. So and the symbol which is used to perform bitwise or operation is just like, you can say, this is the pi symbol. So you can, you just like, if you see or operators, um, just like you can see or operators, I will show you. If you see or, I will copy it, and you can see, you can paste here, and bitwise I will write or this is the pi. This symbol is above the enter key. You can use it. So I will use here the pi, and if you print it, what is really happening? 7. So how is 7 come? Because 7 comes because I will show you. 7 comes if 1, it compares to variables, to integers. If anyone, if 1 comes in every suppose this is the binary conversion, and both are the binary. If comes 1 out of others, Suppose you can say just like if any of the corresponding bits are 1, then the symbol it will be whatever we use in the um, or operators, the result will be always 1. Suppose we can see 1 1 1 1 1 1. So its or operation is 1 1 1 1 1 1 means it's 7. You can see here the result is 7. The result is the result is 7. So uh, you can see like this. The other is you can see bitwise XOR operators. If the bit XOR operator is performed between two integers, and it will compare each bit on same positions, so and the result will be always 1. If you see 1 1, and the if both are the difference, then 1 is the priority of the XOR operator is always 1. And suppose I will use bitwise XOR, so it is very easy to understand you. Bitwise XOR, I will show you. Bitwise XOR, I will show you like this. This is the symbol of bitwise. If you print it, what is happening, you can see here 3 will come. 3 will come. How is happening? You can see here. Suppose 1 0 1 0 1 0. If the both are different bits, it's always will be 1 1 and 0. So what is happening? 0 0 1 1 means you can say this is the suppose 2 0 2 2 2 3 2 4 8. You can say like this. Suppose and means 2 2 1 2 0 means 1. You can say 0 1 1, and it will be 2 0 2 0 2 4. It means it will always 0. It's always 1 1 2. You can say like this. It is 2 plus it is 1. It means it will, the decimal of it is 3. So it will print like this. So its value is become 3. And the next one is you can say bitwise not operators. It means if you if the bitwise not operation is performed on single numbers, it changes the current bits, so it's complement. So you can I will show you bitwise. The other is I will show you this bitwise not. This is not, and tilde. You can see this is the not. You can see this tilde. This is called tilde. So when you if current bit is 0, then the result will be 1. So I will show you about it just like suppose will show you the things bitwise not in a single number, just like if you say this one and a, oops, you can see if you print it, then it's always -8. So how is it happening? So decimal binary, if you convert it, so what is the difference? The bitwise not operation perform single numbers. It changes the current bit to its complement. So if the current bit is 0, then the result will be the 1, and current bit is 1, then it will become 0. So denoted by the these symbols, and its current is 7, and it will be printed -1. So it will show you the uh, invert each bit becomes 1 and becomes 0. It will suppose, if you see, the suppose 5, if you say it is 5, suppose if you change this value, then what is happening? It will always -6. So it corresponds or add by 1. Suppose if you use 3, then it will be -4. You can just like, you can see the results, what is happening will be printed here, -4. So this is the bitwise operator. And bitwise not operators, that is. So in left shift operators, this operator shift to the bits of integer to the left side by the specific number, just like you can see, just like suppose left shift operators, it will just like, suppose if you consider the number of 5, you consider the integer 5, and we will if you want to left shift it's by bit by 2 positions, the operation will be expressed as uh, this is the left shift operators. You can see here left shift operators. So um, so in left shift operator, just like suppose if you suppose I have a equal to 5, suppose I used here, suppose I have to use a equal to 5, and it will give you, suppose C out shift left. So you have to use a, I can say show you a shift greater than 1, and you can use like this. So and what is happening, you can see here. So it will print obviously uh, 5 in 1. So it will shift by 1. Suppose what is happening, I have initialized the a equal to 5, and it will shift by 1, shift by 1. Suppose if you print in the console, what is it showing? It's showing 5 and 1. So this is the shift left. Shift left, left shift, you can see left shift, you can see here as well. So right shift means if you see this, like if you print it, so you can copy and paste. Oops, and I can show you the right, left, left, right shift, and use this and see what is happening. Something is missing. What is happening? Mm, no, basically this will be this like this. You can see. Mm, you have to put like this. You can print here. You can see like this what is happening. Left shift it will prints by 10. I can show you. Left shift print is 10, and other left shift means it will print by, it will double to the by 10, and it will right shift means it will in the it shifts to the right. It means it becomes now 2. So you can see here. So logical bitwise operator contains bitwise and or XOR NOT and left shift right shift. This is so um, as a whole you can see here this is the um, bitwise operators. So guys, in this video I have shown you the different types of operators in C++ programming language. Just like you can see arithmetic operations, it will perform in mathematical operations. The relational operations, it means compares the variables, and logical operators gives the logic, and bitwise operators it means arithmetic relational logical we use later in the upcoming videos additional things about it. You need to understand the basic concept of C++ operators. It's like a relational we use in control statements, the looping and other logical operators. uh, so far, so this is all about your C++ operators. We have I've shown you the all examples, and I have told you the short definitions of it. So don't worry guys, I will upload this all codes source code in GitHub accounts, and I will post you or give you the links to download the code from the account in description link, so you can download from there. Thanks for watching.